So, a few words about our first keynote. That's Dr. Paul Thomas. He's an associate professor and director of the Fine Arts program at the University of New South Wales of Art and Design. Thomas initiated and co-chaired the Transdisciplinary Imaging Conference Series 2010, 12, and 14. In 2000, Thomas instigated and was the founding director of the Biennale of Electronic Arts in Perth 2002 and 2004, and was the conceptual director and made it happen in 2007. Thomas is a pioneer of transdisciplinary practice. His work takes not only inspiration from nanoscience and quantum theory, but actually operates there. Paul's current practice is based on the research being conducted by Associate Professor Andrea Morello from the Quantum Nanosystems at the University of New South Wales, looking at the probability of the electron superposition in the development of the quantum computing. Paul's previous projects investigated silver, the mirror, and the quantum theories of light and parallel universes in the work Multiverse. Thomas' nano artwork, Nano Essence, which I can say I curated in Adelaide in 2009, explored the space between life and death at a nano level. And Midas researched what is transferred when skin touches gold. The Midas and Nano Essence installations were in collaboration with the Symbiotica, the Center of Excellence in Biological Arts, University of Western Australia, and the Nanochemistry Research Institute, Curtin University of Technology. So will you please join me in inviting Paul Thomas to deliver his keynote. Thank you.
I'd like to start just by thanking Malenti and thanking all of you for getting up so early on a Sunday, on a particularly warm Sunday, I hear, to come here and to listen to me talk and for the rest of the symposium. It is, as like I said, early, and I don't know if you looked at the clock if you had a second, because it's 2:43 a.m. for me, which is tomorrow. My family have already had Sunday, and I wasn't with them, and it feels a little bit strange. But so anyway, so bear with me, and I'll try and get through this rather chaotic ride that we're going to take together, and to see if I can, or if we can make any sense out of what's actually trying to happen. So this paper is an attempt to look at two formal components of catastrophe, which is chaos and uncertainty. So let's start with the cloud. So I'm going to break it up into two parts, really. The cloud as a metaphor for chaos, and the notion of uncertainty. So the cloud now has become quite synonymous for us, hasn't it? We all know what the cloud is in a context. I mean, we know what it is in weather terms, but metaphorically we know that it's a network solution to data archiving and so on. It allows us to gather information globally from anywhere. We just plug into our cloud and everything is then downloadable to us. It's atmospheric, it's the air that we breathe. It's the sort of turbulence and chaos that goes in to something metaphorical to describe something that we're now starting to see as being seminally important. If anybody has lost images between their device and the cloud, know how strange this feeling of dislocation becomes. But I want to start to sort of talk about this air that we breathe and look at the moment in time when the cloud became a metaphor for chaos. And I want to do this, these are just some shots of clouds, by looking at a particular moment in time. And this moment is, does anybody know this? It's Filippo Brunelleschi and his peephole device. And his peephole device is seen as being the sort of father of modern perspective. It's how perspective, let's say, was introduced. It's like, you know, when you don't understand something And like when you were at school and you were doing maths and you didn't understand how to do a maths problem, and you were explained and explained and explained and you couldn't get it, you couldn't just get what was going on, and then suddenly you got it. And you didn't know how you got it, you just got it. And then when you got it, you couldn't get rid of it because you had it forever, which was a shame. But you got it. And the point is you didn't have to be at school to get it, you didn't have to, it just came to you. Now, this device, in the Renaissance, about 1425, something around those sort of dates, because the dates aren't necessarily solid, is a device for changing the way that we see and think about the world. It's the device that objectified the world. It turned the world from a spatial relationship where we could identify with and made us understand the vanishing point. So I'll just describe it a little bit before we go on, because there is a point to this slide apart from the development of perspective in relationship to clouds. So Brunelleschi was an architect, an artist, but fundamentally an architect. And he stood in the Duomo in Florence and painted the baptistry opposite the Duomo. And he painted the baptistry faithfully on a panel that he then drilled a hole in the back of. And so you can see through that hole, when you hold up a mirror in front of it, you actually start to see in the mirror the reflection of the baptistry. And the reflection of the baptistry, when placed over the actual baptistry, was a seamless image. And at that moment, people got what they didn't get before. In other words, they understood perspective. It kind of made that visual rupture, that trigger, that enabled them to see. And so it's a device that once you see it and you can explain it to other people, maybe other people can see it. And so it starts to spread. But this device was used for 50 odd years, they tell me, from people going to see him saying, "Hey, Bruni, can I get your peephole device out and have a little go myself?" They took it along to the doorway of the Duomo, tried it out, got the message. But the interesting thing for us is this bit. He wasn't interested, Brunelleschi, in the sky. He wasn't interested in clouds. They were too complicated. What he was interested in was buildings and spatiality. And so he put burnished silver where the clouds were. And so when you looked in the mirror, you saw the clouds floating by in real time. So, and this is from Minetti, Brunelleschi's biographer, who says, where the sky had to be represented, that is to say where the buildings of the paintings were free, thus the clouds seen in the silver are carried along by the winds that blows. Now you can start to get this idea then that the clouds became part of perspective by default almost. Nature by default was perspectivalized. It's not the intention necessarily to have a perspectivalized view of the clouds, because they're like rogue elements. They don't fit to a perspectival model. And now we've got them captured. Now imagine, let's start to say other aspects. So this is the mirror, if you can get the image, overlooking the baptistry. Now imagine that somebody, like a horse, is going along there, right? We've all got that. And it goes behind the mirror. And it disappears. So you have the sound. So does sound become, again, spatialized into perspective at that moment when you start to not see it but still hear it? So that was I just threw that in as an extra. I hope you don't mind that little detour into sound. But the idea is that what else became part of that rupture that became perspectivalized? Now, one of my favorite quotes is that, and we'll talk about this a little bit later, is that before perspective, people wore space like a garment. Now, can you imagine kind of wearing space like a garment? Like space is enveloping you. So now I'm going to try and explain this relationship to the cloud. And I'm going to try and do it through a diagram. Now, pre-Renaissance, wearing space like a cloud. Now, this is a pyramid. This isn't a trick, by the way. That person's bigger on the right side and the left. This is not one of those optical, oh my God, which is bigger. It is bigger. So here we have power. Now we all know what power is, don't we? It's like God, the king, everybody else. People telling you what to do. So pre-Renaissance, everybody's being told what to do directly from above. So saying, go to work tomorrow, go to work the next day, go to work the day after, and just do what you're told. So you don't need any other idea of spatiality, really, apart from the kind of instructional spatiality of aboveness. So everything is above. Now, in Renaissance time, you started to get people becoming independently wealthy. You started to get merchants doing things independently of this power structure. And so power starts to lose control. Power starts to shift. We're no longer in a state where we can sometimes tell people what to do because they're doing their own thing and they're getting money for it. So how do we gain control again? How do we shift power? And so what we do is we take a pyramid like this and we turn it on its side. And what happens when you turn a pyramid on its side and look at the base? If it was bricks and you wouldn't see anything except a flat base, but if it was like a wire frame like this is, you would see all the lines going to one point, which would be the vanishing point. And so if you move power to the vanishing point, you gain control again because you give people a future. You start to say, hey, you just keep on going to that vanishing point, and when you get there, life will be good. And we all know what happens, don't we, when we run down railway lines to see where they meet. They don't actually meet. So it's an unassailable position of power, but we're all on that journey, aren't we? We're all running, we're all trying to get there, we're all trying to get to that point of sort of stepping up to the next level, as it were. And it's a myth. But the myth was not incorporated in the clouds. The clouds were still random, there were still rogue elements, they were still kind of had that potential to not do what they were told. I mean, how many times have you seen the weather predicted and you sort of see, it's going to be a great day and it's a shit day, or it's going to be a shit day and it's a great day. You know, it's like unpredictable. You never know which way they're going to go, what's going to happen. You kind of can guess. But even internally in the clouds, all the upper atmospheres, all the vortexes and so on is going on. So now we're in a situation where we're saying these rogue elements maybe could be contained. Maybe this notion of perspectival space is the wrong notion. And so we have this idea of the corporate cloud, of the cloud suddenly being now directly above us. So we incorporate the metaphor of the cloud and we re-engage it with power and we put it above. And so you can see in this extract from Lucy by Luc Besson what I'm trying to talk about. So let's see if it plays.
But I have to be honest with you. What you did back there, that freaked me out. To put everyone to sleep like that. Do I need to be worried?
No.
Good.
Yep.
Now, I show you that because you can start to get the image quite quickly of this direct relationship now with the cloud and information coming directly back down to you. So the information is coming streaming down to your device. In some godlike manner, you suddenly get this message that you have to go to a meeting, or you get this, or you get this. And this imaging of where this data actually exists, although we all know it's underground somewhere in a big bunker being cooled by gallons of electricity, we have this idea that it's above us, that it's floating. And so I want to sort of say, okay, and now, oh my God, what's Paul done? He's put up an image of a painting that happened to start to just discuss how artists were maybe starting to see this relationship of power and this corruption, let's say, of power. Now this is Turner in 1844, so a long time after the Renaissance, but at a time that's really maybe significant to us. It's just coming to the end of the Industrial Revolution, the Industrial Age, and we're starting to see somebody visualizing this Industrial Age. Like the whole of the country is starting to become machinic, it's starting to be chimneys, smoke, everything else starting to happen. And we get Turner painting this, but not only painting this, but painting the atmosphere, painting the clouds, making the clouds and the smoke and the atmosphere all part of one thing, to challenge maybe and question the actual industrial revolution that's actually happening. Now, he sort of understood maybe things that now we start to see as being significant in relationship to the idea of the cloud and the idea of what the cloud as an information source could be. And if we were to start to look further into this and the relationship between this and the idea of that notion of atmospherics, and if we look at this in 1941, there are people that relate to his meeting with Faraday, who was part of understanding electromagnetism. And Faraday used to do that experiment, you know, when you have a magnet on north and south and you put it under a piece of paper and you put metal filings on top of it, and the metal filings give you this sort of north and south. But imagine then having some invisible force being visualized by magnetic filings. I mean, we all know it now, but when it was introduced and maybe when Turner saw it, maybe you could start to see some of that as an affect within the painting. So maybe he was on not just painting the idea of magnetism, but maybe he understood innately some of the forces that were coming into play and what science was actually telling us at the same time that science was telling us. So we have this correlation then between this atmosphere. But what I want us to see in this is that the cloud is not an object but an experience, and its particles are the very building block of a molecular aesthetic in which we live, breathe and act. So if we're breathing in the cloud and the cloud is data, then surely we're data, because we're actually breathing in these metaphors. Now if you believe in the metaphors, then the metaphors are real. I mean, we all believe in the world as it is, as we see it, so therefore the world to us is real when we see it. Now, drawing breath on a cold day, which is not difficult here, a bit more difficult in Sydney, the lungs fill with air, an invisible cloud, only to be visibly formed as it is exhaled into the cloud, into the cold morning air. The molecular cloud in the physical body is the site where the particles combine in the act of inhale and exhale. So we've got this idea of the cloud now as being coming from the shifting of power from the future to above our heads. And now we're starting to see the cloud as this data, but starting to see a relationship with materiality of molecular bits of information that appear as ideas in the cloud. And bits are the same as like qubits within physics. They're the single bits of data, like the molecules. And this relationship between that and the molecular can start to be seen as forming a relationship with our understanding of data. Now I want to show you a little bit about where this idea then affected art in a more contemporary sense. So I'm sorry, but we're jumping from that time to 1980. A bit of a big leap, but an image that you would have all seen, I expect, quite a lot. So I'm sorry for repeating some of these things, but Kit Galloway and Sherry Rabinowitz did this project in 1980 called A Hole in Space, and it might strike some chords with some of you, so I'll just play you a little bit of it.
Center in New York City.
You're in New York? Are you? You're in New York? Is that your cell?
Is your screen way up off the ground?
Who are we talking to? Are they actors? They look like young people in a show.
They're just people like you and me.
My God, it looks like chorus line having a little lunch break. It must
They
be.
just walk by someplace and like they're just talking because they saw this and
Yeah.
we saw it.
How did you get here?
They're probably.
Just walk.
You're in Century City.
Yeah.
And then see Century Plaza. Oh, Century Plaza.
What's that? Century City is what?
I don't know what Century City
I think
is.
it's a mall.
Do you know where Century City is?
It's in Los Angeles.
I never thought, where is it?
I don't know, ask him.
Hi! Where are you located in Los Angeles? Where is Century City? Century City. Where's Tommy?
Do we know what's going on? Do you know what's going on?
No, not really.
They're in New York.
They're in New York. I'm in Los Angeles, right?
Are you?
Yes.
So in 1980 then this notion then of things that we're all used to now with Skype, but you can still see some of the things that happen when we use our mobile devices were happening back then. Where are you? What's going on? There's a sort of disbelief in this notion of a kind of global, let's say, concept. And to bring it back to maybe an Australian connection, we've got a little bit of this within the extract quote from Roy Ascott, who Malenti brought out here, who was one of the seminal thinkers in this area towards a network consciousness, even the language now, and it was a Western Front publication, Art and Telecommunications, so it was one of the first real books on art and telecommunications. But he says, in trying to describe this, what I'm seeing as the choral relationship between the atmosphere and the clouds, is numerous writers have attempted to describe the enormous changes that they see occurring in human awareness, which some see as a kind of planetary consciousness. Teilhard de Chardin imagined a noosphere, a thinking layer enveloping the biosphere of the Earth. Peter Russell has more recently advanced the hypothesis of the emergence of a planetary brain, which may put us onto the threshold of a completely new level of evolution, as different from consciousness as consciousness is from life and life is from matter. A global brain, which will result in a shift in human ego-centered awareness to a unified field of shared awareness. Now this in 1980 was seeing this space, this idea of this atmosphere around the world, this idea of this sort of global sense as being a shift in consciousness. And so the question is it a shift in consciousness, and has it really transformed the way that we thought it was? Or has it become problematic, socially problematic, in what we thought was going to be this, I mean, partially a hippie dream that we all had of communication in that time frame, that we were going to start to maybe deal with ego-centered awareness. And so has selfies become something that's an ego-centered awareness that's global? So I'm trying to then situate that this was the sort of beginning of this notion of data being all around us at all times. And this is Roy Ascott in 1983 doing The Pleasure of the Text. It's in French, The Pleasure de Texte, but I don't speak, so it's The Pleasure of the Text. Now you can see here the device. Now, so a little bit of self-history. I'm in Perth in 1983 when an artist in residence comes from, and he doing a fax project linking up Australia, and he brings with him a typewriter with a plug-in for the telephone. And this lands in my, now you all know Perth is the most isolated city in the world, don't you? I mean, it's about the only fact you might know about it, apart from John Glenn said it was the City of Lights when he flew over it. And so now it's the City of Lights, whether it was or not. But I think when you're that far away from anywhere, then lights would have maybe been an attractor. I mean, flying over Europe, you'd go, that's the city, this, you know what I mean? So we're isolated. 3 days drive to the next nearest city is isolation. So you can imagine the power that this had on me when I first saw this device, and it linked up to IP Sharp in Canada. And suddenly I wasn't isolated anymore. Suddenly I was part of a network of people that were thinking in a global sense. So, how are you going? I haven't destroyed you all yet, have I? You all good? Okay, I'm sorry about this. I mean, I should really be doing some sort of much more light-hearted routine, something that was like had a lot more jokes in it or gags, but I'm doing my best. So at least I'm not reading from the paper, which had just been really flat. Okay, I'm going to ask you a question now, and so we're going to try and get onto some of the quantum stuff. What takes place when you observe an artwork that appears to naturally summarize what you actually see in the world? You ask the question, what would the world be like if this artwork was going to truly predict what you could see as being the world? Now, we all know that to some extent in quantum mechanics and in the notion of uncertainty, we're in all places at the same time until we observe it. And art is very much about this notion of observation. So in this it says, by Sears, atoms are not souls, the soul itself is atomic. So let's see what that might mean. So I want to take you to the other point in time. So we had 1425 when clouds became a metaphor for chaos, approximately. And now we're going to 1927 when Heisenberg does his theory of uncertainty. So in it, he produced a paper in 1927 on the perceptual content of quantum theoretical kinematics and mechanics at the Solvay conference. So he's presenting this, that when you have the motion, you can't measure the position. When you can measure the position, you can't measure the velocity of something. So the world became immeasurable at that point. Now, this was disputed by these people. Einstein, Podolsky and Rosen in a famous rebuttal of the Heisenberg. If there's any physicists in the room, they can see me afterwards and correct me on this stuff, because I just want to, I should have done this at the beginning, done one of those, what are those things you do when you deny all responsibility? Disclaimer. Yeah, disclaimer. I should have done a disclaimer to say, A, I'm not a physicist, B, I'm not a historian, I'm not a theorist, I'm a maybe poorly educated artist who is struggling with all these things to try and make some sense of where art fits in with them. But they fascinate me. And so that's my disclaimer now. So, now see, John Bell as a physicist has some cool photographs of him. Like, I mean, isn't that much better than that? You know, was that? I mean, you just go, oh my God. So John Bell was Irish, and he came up with Bell's theorem. And Bell's theorem tried to disprove or prove quantum mechanics. So in trying to prove or disprove it, he said that he would try and, roughly, capture reality in the act of happening. So try to imagine that, capturing reality in the act of happening to prove or disprove this theory. And so in 1964 he produced this paper that theorized the fact that that we could or couldn't do this. So from 1927 to 64, you've got to admit the world was in chaos. I mean, nothing could be measured. I mean, what the hell's going on? Meanwhile, by the way, at the same time, Freud had come up with, in 23, was it? The id and the superego and the ego. So that means we were actually emotionally stuffed as human beings at that point as well, because we didn't know what we were or where we resided. And the outer world was stuffed. So you can imagine how artists maybe were going to respond or react to this. There's another one of Bell, and there's an even better one of Bell. I mean, there's a sort of certain disregard there, and that really does show you that they did have very big feet in Ireland. I don't know why. Must be some reason. And then we jump to 1982. I mean, the only cool thing is the tie, I think, at the moment. That's why I'm reading it. And this is Alan Espert, who with some colleagues in 82 did an experiment on Bell's inequality to see if the world we lived in was probabilistic, speculative, or classical, local realism. So we're in a classical world, right? And the quantum world is speculative. And the two aren't compatible. But what the experiment showed, that Bell's theorem was right, and that the quantum world of entanglement, not all of the quantum world, was not compatible with the classical world, meaning the birth of quantum in some ways meant the end of the static object populated world of classical models. So we're in a situation where we've now, to some extent, proved that quantum mechanics. Now, when I say proved, they're all about probabilities. There is no proof, there's just a probability that it's true. Now, I think this is very much to do with art. The probability or seemingly true. So what happened in, I'm just looking at the clock again. So what happened in between those dates, 27 and 82? Now remember that we've just seen an 82 moment, haven't we? Really? We saw Roy Ascot and we saw the Hole in Space project. So this is all going on when this is going on. And these people are not unaware that these things are going on in relationship to what's happening in the world. It's not like an artist only looks at one thing. Now, when we've talked about Freud and the ego and so on, we often associate surrealism with this type of thinking. But what if, according to Gavin Parkinson, if we took the idea that they were also phenomenally interested in what was happening in quantum theory. So he says, the peculiar difficulties faced by artists in finding a language for a new reality revealed by the physicist, and argues that the relocation of surrealism in a discursive field which includes quantum physics discloses the rationale behind its artist's shift to semi-abstract language. So imagine, like Turner, that you're aware that something's going on and you have to generate a new language visually to express it. Now, can you imagine the complexity of that? And I'm sure you can, because I'm sure you've all at some stage had a realization of something and said, I want to express this, I want to express this idea, but I want to express it visually. Now, when I mean visually, I don't just mean image. I mean, we can talk about every other medium for artists use for forms of expression. But I want to turn to one artist that Gavin Parkinson references, and that's Roberto Matta in 1944, who produced this image. And I've got some details about it. But you can see that he was a South American that came to, you might not be able to see it because the spotlight's on me, but I'll show you some details and then hopefully you'll see. But if you could see that he came over and joined the Surrealist movement from in France and then started to work. But what I wanted to try and get across is this relationship at this moment in time to trying to understand what physics is actually telling us and then trying to express this. And so these are just stills. And this painting, I read this, but then I was in New York and I went to the gallery, because everybody does, and I walked around the corner and there it was. And it was an amazing moment to be confronted by this, because it's kind of, for me, it has a lot of the ideas that I'm interested in discussing. What? So I thought I'd throw in a bit of local colour at this moment, just to break the tedium of what I'm talking about. This is a great shot, yeah? I love this. I took this yesterday when I was walking with Nina, and so I threw it into slides, so it's like latest up to the minute news. And it's an irresistible photograph for me. I don't know if any of you have done much painting theory at the moment, but the blank has become quite an interesting topic in painting. But this is a thing that I want you to just experience with me at the moment. So I really got that because it talks about blankness. And in some ways, blankness is like the void. And the void is like the sort of background radiation in the universe. I mean, it's an amazing kind of concept. You all know that we only know 4% of the universe, don't you? So 96% we don't know. I mean, how cool is that for percentages? People who work with percentages. I mean, they say, well, 60% of the population don't like this. I mean, the 60% of the 4%? I mean, it's like nothing. Who cares? 60% of the population do that. I mean, get lost. I mean, I care so little about percentages now that it's amazing. Now, imagine this is a blank sheet of paper, and you're all artists, and you're going to make some marks on this piece of paper. So it can be representational. You could be thinking of an object, you could be thinking of nothing much at all. But what you're going to do is bring the world into existence by your touch. You're going to touch that piece of paper, and your first mark is going to be indicative. Now, the paper is in a stasis. I mean, it's all solid, it's held there in a classical world. And when you start to think about it, it's actually not static, but we'll talk about that. But if you imagine it's like the universe, it's in a stasis of potential. It's like a plane of immanence waiting for something to happen. It's like waiting for the Higgs boson to suddenly become the God particle and all of the cosmos to start to form. It's waiting for that. And you're the artist with a pencil which is a huge responsibility, and you make your first mark. Let's say you're drawing this cup. Good idea. And so I make my first mark about the cup. And it's got to be probabilistic, hasn't it? I mean, look how much space I'm trying to draw. I'm trying to draw plastic, I'm trying to do water, I'm trying to draw gravity, I'm trying to draw all these different things which are inherently within this world that I'm looking at. Now, when I'm not looking at it, it's in every other state it could be and every other place it could be. Because it's in complete chaos. When I turn around and observe it, it becomes classical and we see it, but I start to make marks about it, knowing all these problems exist. And knowing that I'm trying to measure something that's unmeasurable, because we know this from... So I make my second mark. My second mark now challenges my first mark and questions the variation and validity of that. My third mark then becomes more problematic, because now I'm challenging my second mark and my first mark to their actual position and place in space. So you can see that exponentially, when I've got 20 or so marks on the piece of paper, I'm dealing with a problem far greater than most of the physicists can actually deal with at any one moment. Now, I'm hoping there's no physicists in the room now, because they might contest that, but I think it's pretty uncontestable truth. So this then grows. So I want to ask you, then the question is, does this start to talk about this same thing? Does Giacometti drawings, which obviously he's not very good at drawing, you can tell that, because he's made a huge amount of mistakes. I mean, you should be able to get that right, shouldn't you? Well, of course you shouldn't, because it's highly problematic. I mean, none of us can draw a figure like that. It would be impossible. I mean, A, the figure's in a constant state of flux, it's growing, it's changing, it's shifting. B, your perception of it is evolving every second. Your brain is ticking over, refreshing. You're seeing more, you're understanding more. So you're making this person come into reality. And you can see Coldstream, who was a contemporary in the UK, whose most English drawing school is based on Coldstream's drawing methodology, would understand that this idea, I think he took almost 7 years to try and do a portrait of somebody. I think it took, like 27 sittings or something. I mean, this is cool stuff. This is like, we could jump back and I could digress, and we could go back before 1927 and look at Duchamp's standard 3 stoppages as an artwork that really questioned measurement before Heisenberg questioned measurement. So you can see what I'm trying to do. I'm trying to put artists in the frame here. And I can show you that in 1949 he did that, and this one is 1953, so he didn't necessarily get any better at it. Because it's impossible to necessarily get better. Because what you find is that if you make these drawings and you actually question the world, every time you question the world actually becomes more complicated. It never becomes easier. Drawing always by default becomes more difficult to do. It's not an easy thing to actually try and record the world that's unrecordable. Okay, so now back to physics. I like this diagram, partly because of the Francis Bacon-esque type of marks in the back. Francis Bacon the painter, not Francis Bacon the scientist. That's Richard Feynman, the father, let's say, of modern quantum mechanics. An American, interesting, charismatic speaker. And he posited, so I'm trying to get on to, let's say, a shift now into the work. We've established that the whole world is insane, and we're pretty insane in trying to represent the insanity. But hell, what else would you do on a Sunday? And Feynman said in his 1982 paper, which posited the concept of a quantum computer, partly because if you're going to deal with quantum material and quantum ideas, then they are not compatible with classical ideas, and the classical computer can't deal with quantum ideas. And he said, I'm not happy with all... Sorry. And I'm not happy... I got it here. Yeah. And I'm not happy with the analysis that go with just the classical theory, because nature itself isn't classical, damn it. So he gets emotional. I love that. And if you want to make a simulation of nature, you better make it quantum mechanical. And by golly, it's a wonderful problem, because it doesn't look so easy. So I think this idea then, if you're starting to think that fundamentally inside all of you are these atoms and electrons that are going off all the time, and not one of these atoms and electrons actually touches each other. So fundamentally, you're just a mass of bits that don't actually join together, which is a little bit disconcerting, I think. But Max Tegmark, a physicist in the States, has been suggesting that I conjecture that consciousness can be understood as yet another state of matter. Just as there are many types of liquids, there are many types of consciousness. Now, so I'm trying to now get to my interest in the quantum world, because it's trying to say that we have dealt with certain issues, and the issuement of measurement is a difficult issue to deal with. So consider first setting up the condition for the experiment. This is like the drawing. We begin with a vacuum. Now, if the vacuum is the absence of everything, of all matter, how can we be sure that we have nothing at hand? We'll need to do a measurement to confirm this. We could shine a flashlight on the vacuum or use some other probe, but that would introduce at least one photon quantum of light onto the scene, thereby destroying the very conditions we seek, like turning up the light to see the darkness. The situation is reminiscent of the mutually exclusive condition of impossibility that are at issue in Niels Bohr's interpretation of quantum physics. So, we start to see that the artist is also dealing with the notion of measurement. But the beautiful thing about the hand and the eye is the understanding that it can't be measured, but it should be attempted to be measured. And it's affecting the idea of measuring the world that shifts our understanding of what the world could look like. So, his conjecture that is there, but I wanted to put that in relationship to what Tom had written, in relationship to what we're going to talk about now, which is down and turn in the notion of catastrophe. Because we're going to talk about the spin of the electron, and the spin of the electron is the turn, and the turn is something that's a phenomena within this. And I wish I knew more about it, and I wish I could help you with it, but I can't. But I can explain what I know of it, but don't believe a word I say. So I'll just talk over this. This is an experiment that's been happening in the UK. Now, I love the fact that they turn this into graphics like this. This is, I find, amazing, because this is like the outreach that science likes to do through graphics to try and explain it. These are these are nano buckyballs, and inside the buckyball is a nitrogen atom, a nitrogen electron, let's say. And these are nanotubes. Nanotubes are made of carbon. The buckyball is made of carbon. The inside is made of nitrogen. Now, carbon is quite familiar. You're all familiar with carbon because 18% of you is made of carbon. So you must be familiar with it because that's what you are, 18% of you. Yeah? So you've got a natural affinity with it. It's like a blood brother. So these then form these tubes, according to this, then lie across these diagrammatic circuits. These then inside the tubes are then influenced by waves of signals. And these signals excite the electrons and encourage them to spin the nitrogen. And from the spin, we get data. Now, a qubit needs to be in entangled two states of electrons. So we need to have two of them entangled together. Now, how the hell does that work? So now we're making computers, thinking processor out of the same stuff that you're made of. Now, obviously, there's only a few chemicals in the world, and so it's more than likely that we're going to be made out of some of this. But in the work that's happening in UNSW, that I'm lucky enough to be able to talk to the people that are making it, is that they're trying to control the spin of the single electron that's phosphorus in silicon. And how it works is that, you know, a classical computer is zeros and ones. It's either on or off, yeah? So you get the speed from the on and off. So they freeze the state, so there's no other electromagnetism in there. They put an electromagnetic field around the electron which holds it in a downward state. And this is get confusing, so I'll just skip right through it because I know it does everybody's heads in. But fundamentally they put it to a superposition. That's somewhere between north and south. They don't know where it is, but it's a superposition. They use the power of the superposition to get more data. So two entangled qubits together have the ability to do 4 bits of data. So now it doesn't sound much, but when you do it exponentially and you put them together and entangle some of them together, they've got the processing power that's phenomenal. Because they can use the superposition to do this. And this is a position where we don't know where it is, and we can't measure it. Because if we measured it, we'd know where it was, and therefore it wouldn't be a superposition. So it's impossible to measure. You only can affect it, and you have to keep it in its quantum state. So they send a microwave signal, and it affects it. So I've been using the data from this, and the data from this starts to generate a probability of where in a position in the Rabi oscillator that they call it, the electron. So this is tracking the data probability to show where it would go in space. Now it's not the actual, it's a probability. So for every 200 experiments that they do, they get one number out. And that one number is a coordinate spatially where they believe it to go. So I'm interested in this because of the notion of how it's going to affect our consciousness, or whether it is consciousness. So by retaining the Epicurean terminology and saying that the conceptual approximation of virtual infinity moves as fast as thought, Deleuze and Guattari imply that virtual infinity itself moves faster than thought at swerve speed, rather than atomic speed, so to speak. So does the spin apply to swerve speed? So this is the data that we got. It doesn't look like this. It's mostly numbers. So we put the numbers into processing to try and get a visual line. And so you can see that these are all, each one's an individual line, and where they bump is where they affect. And it becomes like this. Remember we talked about this fabric of the universe? It becomes like a bit like a fabric of the universe. So I try to draw it as well. So I don't just do things on computers, I try to draw the experience. That's graphite on graphite paint, so it's, and that's the sound of the microwave signal that is translated, so the direct light signal being translated into sound. And there's me trying to also make it into a 3D model, so to try and create probability waves. And then I got to the point of trying to read to it, and read to it some of Feynman's text, which is a weird thing to do. So this is me reading
with the
to the
probability
electron.
in classical physics, and therefore the problem is, how can we stimulate the quantum mechanics?
And this is the voice you can hear.
There are two ways that we can go about it. We can give up our rule about what the computer was. We can say,
Yeah, it took me a year to
Let
get
the
them to agree
computer
to doing
itself
something as insane
be
as
of
that.
quantum mechanical elements, which obey quantum
Because they just didn't know why I
mechanical
wanted to do it.
laws. Or we can
But I was
turn
trying
the
to
other
say
way
that the
and
microwave
say,
signal has no
let the
conceptual framework
computer
at all,
still
apart
be
from
the
microwave
same
signal
kind that we
itself
thought of
as being a
before.
strength. But if you
A
train the
logical,
microwave signal as being the
universal
voice of
automaton,
Feynman talking to the
can we
electrons that he
imitate
was
this
thinking about,
situation?
then maybe we've got an interesting loop here of information. And so that generated the idea of trying to create a visual expression of this, which is the work that you can see that happens with the sound, which is I'm trying to start to see how this could reflect a relationship to the generation of ideas and the speed of ideas. So I'm getting very close to finishing now, but what I want you to see here is I'm not moving that mouse arrow button, it's just an illusion trick. See my hands up here? Oh my God, is this some connect? So it's a three-dimensional ball, and these things are trying to fire around the space, following where the Rabi oscillator would do. So it's actually taking that data and positioning these images as though the computer is trying to process data, so it's trying to think. But could it happen at the speed of infinite speed? Can the superposition happen? So therefore, the question I have for you is, could the quantum computer rival intuition? Anyway, so, big data sets, back to something normal. Well, we hope it's normal. So, this is Cézanne painting his mountain that he painted, Mount Victoria, or Saint Victoria. Now, why am I showing you this? No, it's not one of those Ferris Bueller Day Out things. You know, anybody. It's a movie reference. God, I thought you'd love a movie reference. So here we have Cézanne. He's painting this mountain over and over again. And he's trying to develop a language for seeing this. Now, we all know where the spin comes from, and we all know where the atomic swerve comes from. And where does the atomic curve from? It comes from some extent from Lucretius. And Lucretius was a Roman Epicurean who understood that there are no such thing as nothing, that everything is something, therefore everything is atomic. So so the smallest bits have to be. So he's sitting on his mountain, near his mountain, adjacent to his mountain, because if he's on his mountain, he can't really paint it, because you can't see what you're on sometimes, can you? Like the wood for the trees. So he's sitting there talking to this person, and this is from a text on correspondence with conversations with Cézanne. And in order to paint the landscape correctly, first I have to imagine the geographic strata. Imagine that the history of the world dates from the day when two atoms collided, when two whirling eddies, two chemical dances combined. These great rainbows, these cosmic prisms, the dawn of man over the void. I see these things rising. In reading Lucretius, I saturate myself by them. So does that mean that he actually understood when he was painting about the quantum atomic nature of things? I mean, you can see in the work of Seurat that you could make those choices, but in the work of Cézanne, you start to see something else. So I'm trying to say that in this, and I'll try and read a little bit of the final part, making the world happen at the speed of thought as it represents being, but through the artist's marks, that question and challenge, that a problem finding there is a potential for swerve speed to occur. The continual testing of the world around us through artistic lineage and creative manifestations enables a critical questioning that is significant as that of the realization in science of uncertainty and probability at the core of the quantum reality. The work of Cézanne and Giacometti, and like artists that are already working in this exhibition at the Age of Catastrophe, here are part of an ongoing expression that are connected to works becoming
works that attempt to summarize the world and what the world would be like if their becomings were the world. And I'll just finish with this quote from Roy Ascott because I like it. There's no other reason. But molecular robotic, positional assembly and self-replicating suggest exciting possibilities for moving atoms around, building new materials, manufacturing nanomachines, and generally building the fundamental blocks of nature into the configurations we desire. There is a danger that the outcomes, even when beneficial in engineering, medical and social items, could be spiritually hollow, and as such would exacerbate rather than relieve the excessive materialism of our time. And so I think that's really interesting in relationship to materiality. So, thank you very much. That's my website.
I think there's maybe 5 minutes for some questions, so maybe 1 or 2 questions. Yeah, Monica?
Yeah, thank you very much for your talk. I'm also excited about this connections between artistic and between scientific. And I like how you pointed out that we only know 6% of our universe. But I also think that there's another thing that probably we don't usually think about, that if we knew 100% of our universe, we would actually not know everything, but we would know nothing, because the information is always abstraction, right? And so I would say that creation of information in this sense is exactly abstraction from this overload of information with which we're confronted. So, for instance, this artist is confronted with white sheet or with blankness. What you've described as blankness is in fact confronted by overload of information, because light as pure information, if we would see everything as pure information, we would basically see nothing. So what artist does is taking away information in order to be able to create meaning, pretty much. And so in this sense, I liked when you showed the visualization of measurement of superposition of electrons. You see that it's just this fabric of noise, of overload, right? Which you then, when you used it in a different graphic artistic presentation, you had to take away more information in order to. So it wasn't like the artistic representation of this fabric was already something different, even though maybe for you it came from this, it was inspired by this sort of measurement. So the more, basically the I guess what we should learn from this, when we're more and more able to measure probabilities, we learn that everything is just a fabric of probabilities, and that the further we go, the less we're able to form information and know.
No, I think you're right. I mean, I think there's a reductionist thing that happens within that. And I think artists, when they're trying to, and my thing would be that Cézanne, looking at one of the largest data sets, if you take data as being visualization of this data, and you take all data, then the landscape is this huge data set. I mean, and then to try and translate that spatially and understand that. And also with the whole education that he had, and being a scholar, and understanding Latin, understanding Lucretius, not that he necessarily tried to, but just part of his being, that he's trying to synthesize all that together and give us a becoming, give us a now. And so that's what excites me about what the potential for art is, to try and tackle things, to try and express them, and to internalize them, not just mirror them, not just give us the data and then mirror it back out, but internalize it and start to give us an expression. Hence, in the work I tried not to put any scientific instruments there, or just to give you a visual expression of something that I think has an aesthetic quality to draw you in. Now, if you want to find out more, like with any artwork, if you want to find out more about Cézanne's work, you start to read through. But it's there, but it is. I mean, anything we do, we could never know anything, everything. I mean, it's impossible to start to... But the idea is still that we inquire. That's the beauty of it, is the inquiry. I mean, who'd want to know everything? I mean, I wouldn't. Jesus, it would be horrible. I mean, I can't stand the thought of knowing more than I already know sometimes to think I can't cope with it emotionally.
Well, it could be just nothing, right?
Well, I mean, you know, it's a...
It
when
could
you-
be just monotone, like overload.
But when you
Like
think,
pure light in your
yeah, but
eyes.
when you start to think of like pure light or photons, what photons do, how photons travel, the way that photons work, the double slit experiment, the way they're particles, the way they're waves, I mean, even that is highly problematic. You know, it just gets more and more complicated as we move on. Yes,
I have a quick question about modes of representation. I was fascinated by the way that you visualize the history of art in the paper, because when you talked about the space in which the first mark is a mark of anxiety, and then the second mark has a relationship, and so on, that's the classic statement of the kind of existential dilemma that the abstract expressionists went through all the time. That was the problem. It's the first mark, and the bare canvas was always a problem. You go from that to Giacometti, who is in fact a representational painter. And at the end of your paper, you end with Cézanne, who is seen generally as the beginning of abstraction. So what interests me is, in this question of representation, can you tease out a little more what the relationship between representation and abstraction would be in pictorial language?
I mean, this is where my failure as an art historian comes in. But so the interest for me is that to try and discover new languages, they're a kind of a roadway, let's say, and it has to become more abstract. I mean, what Parkinson said is fundamentally true. I think that, you know, to try and come up with a new language for expressing the world that we can't comprehend, the invisible world, the ability to measure it. But I think in some ways that doesn't deny these two things coexisting, as in not in a binary relationship. I mean, trying to draw a cup of water is inherently all the problems of that. So even though that there's a sort of figuration, I think when you start to look into Giacometti's work, you know, and it depends on, you know, there's a lot more we could talk about scale, about position of human, about egocentric, you know, the observation and the ego in relationship to that. But if you start to, let's say, move in to Giacometti's paintings, you enter a world of complexity. It's like I did a paper on the probability of Feynman's diagrams and Francis Bacon's work. I mean, Deleuze wrote a book on Francis Bacon, and he has a whole chapter on Bacon's paintings as being that very abstract background, diagrammatic, scrubbing and moving marks around until the painting starts to form, as is similar to the sort of diagrams that Feynman was starting to visualize a new language through the diagram that expressed mathematical equations, but and if you look at those in relationship to Paul Klee's sketchbook notations about how marks are made, you suddenly start to see that these lines that have so much potential meaning. If anybody wants me to read their signature, I can. Like if you want me to tell you all about your life and what you're about and, you know, the mess you're in, I can do that from reading your signature. I just wanted to throw that in there, but when you take a signature and you pull the ends, it's just a line. But I can spend 20 minutes talking to you about that. So if I can spend 20 minutes talking to a line that represents you, when you look at a Matisse, how long could you talk about it for? That's another question back at you guys.